Okay, in this video, we're going to use the Fundamental Theorem of Algebra to find all complex zeros. So in the last example, we saw that x to the fourth plus x squared minus 12 equals 0 had four total solutions. We had two imaginary solutions, 2i and negative 2i, and two real solutions, square root of 3 and negative square root of 3. And that's actually not an accident. There is a way to check to make sure that you've gotten all possible zeros, whether they be rational, irrational, or imaginary, and that's using the Fundamental Theorem of Algebra. So the Fundamental Theorem of Algebra states that if we have a polynomial, f of x, and the degree is n, so in this example, the degree of this polynomial is 4, remember degree is the highest power of our variable that we have, then our function is going to have four total, or n total in general, complex zeros. Now remember, a real number is a subset of the complex or imaginary numbers, because we could write the square root of 3 as the square root of 3 plus 0i, and we can write negative square root of 3 as negative square root of 3 plus 0i. So if we have a purely real number, we can make it a complex number by just putting a plus 0i afterwards. So this is a nice technique to use and apply for making sure that you've gotten all possible solutions, whether they be rational, irrational, or imaginary, to finding the zeros of a polynomial. So again, keep in mind a real number such as a, like square root of 3, can be written in complex form as a plus 0i, or square root of 3 plus 0i. So here's what we're going to do. We're going to break this down kind of in the same order we did the other videos here. We're going to start by finding the rational zeros. So we'll list out the potentials, and then, just like we did in the first video for this section, find the actual rational zeros using the rational zeros theorem. And then we're going to use division to get it down to the lowest degree that we can. So we're going to take any rational zeros that we have and just sort of whittle away at the polynomial and keep knocking it down a degree each time we use division to get it down to the lowest degree that we can. And then we can use the quadratic formula, or maybe the technique of the example in the last tutorial video where it was in quadratic form, to find the complex or irrational zeros as well. So we're going to find all the zeros for our function 12x to the fifth minus 20x to the fourth plus 19x cubed minus 6x squared minus 2x plus 1. Wow, that's a mouthful. So let's start by listing the potential rational zeros. So all the factors of 1 over all the factors of 12, and we'll put pluses and minuses in front of them. So we have 1, a half, a third, a quarter, a sixth, and a 12th, all with pluses or minuses. So let's see, this is 1, 2, 3, 4, 5, 6. There's 12 possible rational zeros. So don't forget the positive and negative for each. So looking at the techniques, we can either look at the graph or the factor theorem and all that. Our actual rational zeros are going to be at x equals a half and x equals at negative 1/3. So let's start with x equals the half. So if we subtract a half from both sides, we get x minus a half equals 0. So our factor is x minus a half. So that's why we have a minus half here. I'm going to go through this rather quickly for the polynomial division, try to keep the video a little bit shorter. But 12x to the fifth divided by x is 12x to the fourth. 12x to the fourth times negative a half is negative 6x to the fourth. We combine negative 6x to the fourth with negative 14x to the fourth to get negative 20x to the fourth. Negative 14x to the fourth divided by x is negative 14x cubed. Negative 14x cubed times negative a half is 7x cubed. We combine 7x cubed with 12x cubed to get 19x cubed. 12x cubed divided by x is 12x squared. 12x squared times negative a half is negative 6x squared. We combine negative 6x squared with 0x squared to get negative 6x squared. 0x squared divided by x is 0x. 0x times negative a half is 0x. We combine 0x with negative 2x to get negative 2x. Negative 2x divided by x is negative 2. Negative 2 times negative a half is 1, and everything's accounted for as it should be. So whittling this down a degree, we have 12x to the fourth minus 14x cubed plus 12x squared minus 2. Now, if we evaluate that at x equals a half again, we get 0. So x equals negative half has yet another root. So we're going to use x in negative a half again, but now we're going to divide that into 12x to the fourth minus 14x cubed plus 12x squared minus 2. So 12x to the fourth divided by x is 12x cubed. 12x cubed times negative a half is negative 6x cubed. We combine negative 6x cubed with negative 8x cubed to get negative 14x cubed. Negative 8x cubed divided by x is negative 8x squared. Negative 8x squared times negative a half is 4x squared. We combine 4x squared with 8x squared to get 12x squared. 8x squared divided by x is 8x. 8x times negative a half is negative 4x. We combine negative 4x with 4x to get 0x. 4x divided by x is 4, and 4 times negative a half is negative 2, so everything's accounted for. So now let's check out x is a half in 12x cubed minus 8x squared plus 8x plus 4. It's not equal to 0, so we're done with the negative a half, or the positive 1/2 as a 0. We also had the x equals negative 1/3 from our rational 0. So now we can apply x plus 1/3 dividing into this 12x cubed minus 8x squared plus 8x plus 4. And by the way, we could have started with our original problem and starting with this rational 0. It does not matter which rational 0 you start with. So it really, truly doesn't. We'll get the same answer regardless. So now let's look at x, or 12x cubed minus 8x squared plus 8x plus 4 divided by x plus 1/3. So 12x cubed divided by x, 12x squared. 12x squared times a third is 4x squared. We have to add 4x squared and negative 12x squared to get negative 8x squared. Negative 12x squared divided by x is negative 12x. Negative 12x times a third is negative 4x. We have to add negative 4x and 12x to get 8x. 12x divided by x is 12. 12 times a third is 4. Everything combines. If we check 12x squared minus 12x plus 12, if we evaluate that at x is equal to negative 1/3, it will not equal 0. So besides, it's already quadratic, so we can apply the quadratic formula. Well, let's divide everything by 12, since we do have a common factor of 12. It'll make our numbers smaller. We get x squared minus x plus 1 equals 0. And then applying the quadratic formula to this, we get 1 plus or minus the square root of negative 1 squared, but I always ignore the negative. 1 squared minus 4 times a times c, so 4 times 1 times 1, all over 2 times a, or 2 times 1. And we get 1 plus or minus the square root of negative 3 over 2. Keep in mind that the square root of negative 3 is an imaginary number. It's equal to I times the square root of 3. So we have 1 plus or minus I times the square root of 3 over 2. And our final answer for all of our actual complex zeros here are, we get x equals a half. It's a double root, or we also say it has a multiplicity of 2. We have x equals negative a third, and then we have x equals 1/2 plus radical 3 over 2 times I, and x equals 1/2 minus radical 3 over 2 times I. So remember your complex conjugate theorem that says that if you have one complex number, like a half plus square root of 3 over 2i as a root, the conjugate of that, 1/2 minus square root of 3 over 2 times I, will be a root as well. All right, so that about does it for this video. Thanks for watching. I'll see you.